All right, welcome everybody. This is 6.0, Quadratic Formula, and other solving methods. All right, so this lesson isn't really part of Unit 6. It's more like Unit 5. So in Unit 5, we talked about two different ways we could solve. We could factor to solve, or we could solve by completing the square. We would switch it into those forms, and then we were able to solve for x. This is the last way that we can solve, or at least that we're covering, is the quadratic formula. Before we get into that, let's do some simplifying practices. Okay, so a lot of your problems when you use the quadratic formula, you end up getting things like this, and we just need to know how to simplify from that point. So let's do a couple of these. So there's different ways we can simplify whatever works best for you, but basically we want to reduce the numbers or combine like numbers if we can, things like that. So if we want to divide, like this is a fraction is a division, so we could divide everything on top by 2. So we could end up getting something like -2 plus or minus 4. And then we actually know what those answers are, so we should continue to simplify. So sometimes we've left our answers like this because maybe it's imaginary and we couldn't combine those, or maybe we had a root. But if we have two integers, then we should combine those together. So here we got -2 plus 4, so that gives you 2. And then we got -2 minus 4, which should give us a -6. So our solutions would be 2 comma -6. Okay. So here's another example. 8 does not, you can't divide 4 by 8, but we can look at the three numbers and say, well, what can we divide all of them by? So we could divide all of them by 4, and we'd end up getting -1 plus or minus 2 over 2. And then we'd do the same sort of thing that we did before. We would do -1 plus 2, and then we would divide it by 2. So that would give us 1/2. And then we could also do -1 minus 2 over 2, which gives us -3/2. So our solutions would be x equals 1/2 and -3/2. Okay, so again, we simplified the fraction, and then if we can, we'll actually do the plus or minus individually and simplify further. Okay, then you're going to run into things like this. So like the square root of 8. Whenever you think of squares roots, think of simplifying roots. So doing factor trees, 2 and 4, and then 2 and 2. Groups come out. Non-groups, like the 2 that's by itself, stays inside. So we'd get -4 plus or minus 2 square roots of 2 over 2. Okay, and then we'll do the same thing we did before, as we would say, ooh, we can divide the top by everything by 2. So you could do it like this, or you can kind of think of it just as -4 divided by 2 gives you -2, and then 2 divided by 2 gives you 1, so we get plus or minus 1 square roots of 2. Okay, that's kind of how I like to do it, but either way, you end up getting the same thing. If you did it the other way, like if you divided these terms all by 2, I'm not very good with 2s. I need to work on writing those better. Okay, here we'd get -2 plus or minus 1 square roots of 2, and then you'd have over 1. But if you divide anything by 1, it doesn't change it. So we would just write our answer like this. Okay. So that would be our answer. One thing I've had students do is they're like, ooh, 2 goes into 4 and 2 goes to 8. Okay, but you can't do that. You can't divide something that's inside a root. We can't do the square root of 8 divided by 2 and say that's the square root of 4. That is not okay. All right, it's like they're not terms. But if we simplify the root first and find out that we have like 2 divided by 2, then we can simplify that. Okay, so catch that. Don't make that mistake. All right, let's skip to this one. Again, if we have roots, that's like the first thing that we'll do is we will simplify your root. So we could do 3 and 9, and then 3 and 3. So we could take out a group of 3, and we'll have a 2 that stays inside. So negative 6 plus or minus 3 square roots of 3 over 9. Okay? So again, we look at these three numbers. It's like our Three Musketeers. It's all for one or one for all. Okay? So we do it all together. We simplify them together, or we don't simplify them at all. Okay, so what goes into 6, 3, and 9? Well, 3 goes into all of those, so we could divide all of them by 3. So if you want to do it that way, that's fine. You can just do it in your head if you wanted to. So, but we'll end up getting negative 2 plus or minus 1 square roots of 3, which is just square roots of 3, over 3. Okay. All right, and then the last ones I want to talk about, these ones are a little different too. So what do you notice here with our root? If we want to simplify the root, okay, hopefully remember that if we have a negative inside of a root, that becomes an imaginary, and then we can do our factor tree. So we could do 2 and 4, 2 and 2. So we'll end up getting 2 plus or minus 2i square roots of 2 over negative 8. All right, and then we want to simplify the fraction. So what can we divide 2, 2, and 8? Well, that would just be 2. And then one other thing we need to talk about is typically we don't want negatives in the denominator. There's nothing really wrong with it. It's just typically we keep our negatives on the top. So what we'll do that is we will need to divide everything by a negative 2. Not just 2, but negative 2. So that would end up giving us negative 1 plus or minus negative 1i square roots of 2 over 4. Okay? And then let's simplify a little bit more. So this is what I want to talk about here, plus or minus a negative. So if we do plus a negative, well, that just gives you a negative. And if we do minus a negative, that gives us a positive. So basically, if we do plus or minus a negative number, that really is the same as doing plus or minus 1. So that negative doesn't really apply it, because no matter what, you're going to end up having a negative 1, and you're also going to have a positive 1. Okay? So really, at least you'd see it like this more. Like on your answer key, is you would just have something like this. Okay? So we get rid of that negative, because no matter what, it's going to be positive and negative. And then we don't really need the 1 either, because 1 times I is just I. All right? So let's do another example that's kind of like that. All right, so simplify this root. Again, we have a negative, which will give us an I. We'll do our factor tree. So this would be what? 2 and 9, and 3 and 3. So we could take out a 3 in the front, and then we'll have a 2 that stays inside. So we'll have negative 3 plus or minus 3i square roots of 2 all over 6. And then we just need to simplify the fraction. So what can we divide 3, 3, and 6 by? We could divide everything by 3. And we'd get negative 1 plus or minus 1i, or just I, square roots of 2 over 2. Okay. And then last one, why don't you pause and see if you can do this problem? Is there a different problem I wanted to do? Maybe it's something else. Okay, let's see what you come up with. Oh yeah, this is the one I wanted you to do. Okay, so hopefully you paused and gave that a try. This will give us an imaginary. Factor tree would be 2 and 9, and 3 and 3. So we'll have 2 plus or minus 3i square roots of 2 over 2. Okay, so here you may be tempted and say, ooh, here we have a 2 and a 2. Maybe we can simplify that. So again, we can't divide something that's in a root by something that's outside of a root. Okay, and then here you may be tempted to do something like, ooh, well, 2 divided by 2. Well, that's correct. We can divide that, but we can't divide 3 by 2. So here we're actually done because we can't divide all 3 of them by the same number. Okay? All right, so there's just a quick practice with simplifying roots and fractions. And then let's get into the quadratic formula. So we've talked about solving different ways. This is the last way we can solve is the quadratic formula. The thing about the quadratic formula is basically completing the square, where if you were to complete the square using just the letters A, B, and C instead of numbers, this is what you would end up getting, is the quadratic formula. So one note that you need to make sure is that you will need to always have your equation in standard form, meaning ax squared, meaning our x squared term first, and then our x term, and then our constant, and then what a lot of people forget is it has to be equal to 0. So if you have a number that's on the right side, you need to add or subtract both sides so that we end up getting 0 on the right side. Okay, so this is the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is a little song that kind of helps people remember how to do that. You sing it with Pop Goes the Weasel. It goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is a really good tool if you were trying to memorize it. I think it's a good idea, but this is the only lesson that we're going to be using it, and we're not going to test you on it except for like a starter. So typically we do have it part of our Unit 5, but I think it was a little too much. So kind of doing this kind of by itself, and then we won't use this for the rest of Unit 6. Okay, this is kind of standalone kind of thing. All right, so memorize it if you can. If not, you can use it while you do your homework and your notes and your starter the next day. All right, so let's just go into a problem. You can pause here. This is kind of like the steps on how to do this, but we'll go over it together. All right, so first thing we need to do is it has to be in standard form. So this is in standard form, so check. Next, we want to label down what A, B, and C are. Again, A, B, and C are the coefficients, the numbers that are in front of your variables. So A here, this would be like a 1x squared, so A would be 1. B would be negative 9, so the sign is part of it. And C here, our constant, is 15. And then next thing we do, our step 3, would be to substitute that into the formula. So you may want to look at this while we do it, because I can't have both of them at the same time. I guess I probably can. Let's try that here. All right, so we'll do x equals negative b. So a negative b, but b is a negative. Okay, so keep that in mind. X equals negative b. If b is negative, then we're going to end up getting a positive. Okay, x equals negative b plus or minus the square root of b squared. So that's negative 9 squared. Okay, pause. When you substitute a negative, you need to put it in a parenthesis. Okay, especially if you're going to square it. There's a difference between negative 9 squared versus negative 9 squared, at least for your calculations, if you're going to use a calculator. Your calculator would give you a negative 81. But we're squaring the negative as well, so you have to have the parenthesis in order to get the sign to work, because we're squaring the negative, which means it would be a positive 81. Okay, so make sure you put parentheses when you substitute negatives. Okay, so it's x equals negative b plus or minus the square root of b squared minus 4, so it's always 4, ac, a is 1, and c is 15, all over 2, A, and A is 1. Okay, so we substituted everything in. This is where a lot of people make their mistakes, is they make a sign error or forget a parenthesis. Okay, all right, so we've covered those first 3 steps. We put it in standard form, we labeled A, B, and C, we substitute A, B, and C into the formula, and then the rest is just simplifying. We'll simplify 3 things. We'll start with the radicand. The radicand is what's inside of the root. So like, here's an example. Index was like, we talked about those before. This is like a square root. Everything we're going to be doing is a square root. And that's typically not written. The root, and then we have the radicand, which is like what's inside of that root. Okay? So we want to find the radicand. I think it's also called the discriminant. Maybe I should use that. I haven't really used that in the class. So the discriminant is what's inside the root, or also known as the radicand. Okay, so we would plug that in. What I would recommend is to put that into your calculator. Just what's inside of that root. Okay. Let me grab mine real quick. Okay, so including parentheses, make sure you realize that there's a difference between a negative and a subtraction. Okay, can't write that very well. Okay, but your calculator isn't as smart as you. It will do exactly what you say. So if you do a negative when it should be a subtraction, then it's going to do what you told it to do. So, okay, so -9. So put that in, square it. -4. You could do parentheses, 1 and close parenthesis, parenthesis 15. And it should give you 21. So we end up getting 9 plus or minus the square root of 21 all over 2. Okay? If possible, our next step would be to simplify our root, but the only factor tree that we could come up with would be 3 and 7. And we can't take a group out. Also, we would look at our fraction like we did above, but that can't be simplified either. So here, here we are done. It'd be x equals, those would be our 2 solutions. 9 plus the square root of 21 over 2, and 9 minus the square root of 21 over 2. All right, I'd like to see if you can do B. So pause, give this a try. All right, so make sure it's in standard form, check. Label A, B, and C. A is 3, B is 4, C is 8. All right, next we substitute it all in, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we plugged it all in. Now we'll simplify, or we'll find the discriminant, or the radicand, what's inside the root. 4 squared minus 4 times 3 times 8. And I get -80. So we'll get -4 plus or minus the square root of -80 all over 6. Okay, so we simplified the radicand. Now we'll simplify the root. Okay, so we've done like that already before. What do we do if we have a negative? Well, that's an imaginary. And then we'll do a factor tree. So 2 and 40, 2 and 20, 2 and 10, 2 and 5. Looks like we have 2 groups of 2 that we can take out. So that's 2 times 2 is 4. So -4 plus or minus 4i square roots of what's left is the 5 all over 6. Okay, so we simplified the root. And the last thing we could do is simplify the fraction. So we look at the 3 numbers, the 3, change that. So we have a 4, 4, and 6. So what can we divide all of them by? We could divide everything by 2. So we get -2 plus or minus 2i square roots of 5 over 3. And that's it. Okay, so again, here are those steps if you want to pause and write those down. Standard form first. Label A, B, and C. Substitute it into the formula. Simplify the radicand. Simplify the root. Simplify the fraction. Again, remember 3 musketeers. I don't even know how to spell that, so, but I think you get the idea. Musketeers. All right, so we're going to do this one together, and then I'll have you try D. One thing we need to do again is it needs to be a standard form. So we have to add that too. Everything has to be on one side. So 7x squared plus 8x plus 11 equals 0. Please make sure you catch that at the beginning, because I've had people forget and then they basically have to redo the whole thing. Okay? All right. Now we have A is 7, B is 8, C is 11. So x equals negative b plus or minus the square root of b squared, so that's 8 squared, minus 4ac all over 2a. So we plugged it all in, substituted everything in. We're going to simplify the radicand, or the discriminant. So 8 squared minus 4 times 7 times 11. So negative 440, or 244. Okay, now we'll simplify the root. Okay, we have a negative, will give us an imaginary. And then factor tree, we could do 2 and 122, 2 and 61. 61's prime, so we can't do anything from that. So we got negative 8 plus or minus 2i square roots of 61 over 14. And then last thing is to simplify your fraction. What can we divide 8, 2, and 14 by? Well, that would be 2. So we get negative 4 plus or minus 1i, or just I, square roots of 61, all over 7. Okay, all right, hopefully you give this one a try. Pause and give that a try. So plus 12. So we get 5x squared plus 4x plus 4 equals 0. So A is 5, B is 4, C is 4. And then we'll substitute everything in, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we got that in. Again, a lot of these examples, maybe I need more of those, but most of the a, b's, and c's are positive. But again, keep in mind, if it's negative, make sure you put it in a parenthesis. Especially like B, especially with B, okay? All right, so we'll simplify the discriminant. So we get negative 4 plus or minus the square root of, we'll type this in, 4 squared minus 4 times 5 times 4. So I get negative 64 all over 10. And we'll simplify the root. So again, we have a negative, so that will give us a positive, or give an I, sorry. The square root of 64 is actually a perfect square. So if you realize that, then you don't need to do a factor tree, but we could do 8 and 8, and that's a group. So we could do negative 4 plus or minus 8i all over 10. And then we'll look at the fraction. What can we divide 4, 8, and 10 by? We can divide everything by 2, so we get x is equal to negative 2 plus or minus 4i over 5. Okay, so that is basically the quadratic formula. Again, it's kind of like a lot of steps on doing that, but they're all the same. All right, last thing we're going to talk about is kind of comparing the 3 methods that we've covered. There's factoring, completing the square, and the quadratic formula. Let's talk about them individually. So On your homework, you have the choice on how some of the problems. You can choose how you want to do it. I think the first 4 problems, I'll show you right now. So these first 4 problems, they have to be done using the quadratic formula. And on the back side, these last 6 problems, you can choose factoring, completing the square, or completing the quadratic formula to solve. So make sure you're solving, meaning your answer is x equals something comma something, or like something plus or minus something, okay? But these ones you can choose. So you can do everything quadratic formula if you'd like. But some of them I think are maybe a little easier, especially like, I don't know. Completing the square, I think is about the same amount of time, but completing the square. So when we maybe want to complete the square is when A is 1 and B is even. Okay, that makes it really nice because you don't have to like do like that big parenthesis with the 2 or whatever. We end up not having fractions. So all of that's really good if A is 1 and B is even. Okay. Factoring. I would factor if it's factorable. So like if you take out that 2, we get x squared minus 9x plus 14. And then we just need to find what multiplies to 14 and adds to negative 9. So like negative 2x and negative 7x, that would work. And then we could even use the shortcut. So x minus 2 and x minus 7. And then all you have to do is write down your solutions. So again, what makes that be 0? Well, that would be, x would have to be 2. Or what makes that be 0? Well, then x would have to be 7. So those are your solutions, and that's super quick. So if you can factor, that's a good choice. And then C, you wouldn't want to factor because there's nothing that multiplies to 12 and adds to a negative 5. So that doesn't work. And B here, B is odd. So you probably don't want to complete this square. So here would be a good example of where we'd really probably want to do quadratic formula. Okay? Nice thing about quadratic formula is it always works. Completing the square always works, but sometimes it varies a lot on how you have to solve the problem. All right, so the rest is your time to work on your homework. Again, first 4 problems, you have to use the quadratic formula. After that, you can do whatever method you want. But please, make sure it's in standard form. This is a lot of problems. People are asking about this. So make sure we need to move this to the other side so that it's in standard form, using addition or subtraction to move it to both sides. Okay, do it to both sides. Okay, all right, sounds good. We'll see you guys.